Now, if we choose a product, say such as 48, which is in the white area below the diagonal, then the sum of its factors, of course, will be greater than 10. In this case, we have 6 times 8. And 6 plus 8 is 14, which is greater than 10. And that's why when we choose this product of 48, then it falls in the white area of the diamond. Now, if we look closely at the area that is included in the rectangular area bounded by 48 and 1 at the top, then we'll see that it will include some of the white squares along the diagonal. And in this case, it will include exactly 1, 2, 3, 4 of those. And if we look at this area, we will see that adjacent to it will be triangular areas. And we can see that this triangular area includes in this base 4 squares. And if we look to the other side, we'll see a adjacent triangular area which includes 2 squares. So we have 2 on the left side and 4 on the right side. Now 2 times 4 is 8, which happens to be the number of ones in the product, 48. So 2 times 4 is 8. And so we can go up here and find those 8 squares by going 4 times 2 will give us 8. And so we know there should be 40 more. Well, as shown before, there are exactly 4 squares included in that area. And so crossing these 4 squares, we should get a line of 10 squares each to make 40. So let's look. So we'll start here at the 30. Now we're going to go up. Since we're doing 6 times 8, we're going to count up to the 8. 1, 2, 3, up to the 8. And then go 4, 5, 6, 7, 8, 9, 10. And so we have counted 10 associated with this 30. And let's go to the 36. Again, we count up to the 8. 1, 2, 3, 4. There's the 8. Then we go 5, 6, 7, 8. We already counted these 3, so we go 9, 10. And we're at the second number here, which corresponds with, of course, the second number here. The first one was this 30 and then now. And now we're going to go to 42. And we count up 1, 2, 3, 4, 5 to the rod 8. And then we go 6, 7, 8, 9, and we have 10 again. Go back, and then we go to 48, and we count from 48 to cross our last square in the diagonal that's included in the area. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so there we see that associated with the 4 squares in the diagonal included in the area of 8 times 7 are lines of 10 squares, giving us 40, and 40 plus this 4 times 2 here gives us 48 altogether in that area. 48 will be included in this area. Let's try 6 times 8 on the Pythabacus. So we'll count down from the top 1 bead, 1, 2, 3, 4, 5, 6, and push those beads over to the left post. And then we'll count down 1, 2, 3, 4, 5, 6, 7, 8, and push those beads over to the middle. Now we can see here that the white squares that were represented in the area in the multiplication table along the diagonal, the 4 white squares, are now mirrored or represented over here by the 4 beads. And so we already know that 6 times 8 must include 40 beads. Since these 4 beads, as we saw in the multiplication table, will include lines of beads or lines of squares that count to 10 for each one. So that will give us 40. And so even though now we don't have the completed area here, we know that the completed area on the Pythagorean abacus or the multiplication table would include 40 beads. And we also know that by looking at the numbers of gold beads on the bottom of the triangles against the post, that we have 2 times 4, which is 8. So here's our 4. We go 1, 2, and we get our 8, and we push it out. And then we can see that our solution will be 10, 20, 30, 40, 48. And so in this way on the Pythabacus, we can do a quick calculation of 6 times 8. Let's try 7 times 8. So I'm going to count down 7 beads this time. 1, 2, 3, 4, 5, 6, 7. And push that group over against the left post. And I'll count down 8. 1, 2, 3, 4, 5, 6, 7, 8. And push those to the middle. And now we see that we have 1, 2, 3, 4, 5 beads on the bottom that we know must complete an area that will include 50 beads. But we also have 2 times 3 triangles on the end. So we count 1, 2, 3, 1, 2, And we know that for our ones, we will have 6. So our solution is 10, 20, 30, 40, 50, 56 for 7 times 8.